Hello, and thank you for joining me for another video on software design patterns. Today we're going to be going over one of my favorite patterns. It is the builder pattern. The main purpose of it is whenever you have some kind of object that has a very complicated construction process. So you could think of something, just some object. Maybe it has other objects that it has to construct before it exists, or before it can exist and function properly. Maybe it has, a ton of different arguments that you could put into the constructor. Maybe it just has, a ton of different options that are very hard to explain, easily. And you don't want that complexity. Basically, you don't want, other objects that have to use this object to have to deal with that complexity when they create it. So the solution is to sort of offload that construction process to another object. So let's just look at the diagram. Maybe it'll become a little bit more clear. So basically, it's kind of simple. You have the client. Well, I mean, simple. It has a couple levels of, nonsense. But you have the client. It knows about basically this thing called the director. And then it knows about one of the concrete builder classes. So all of the builders kind of conform to a certain interface. And then you have a bunch of different concrete builders. So the director is what actually does the constructing. That's sort of what puts the object together. The builders kind of store their own information, and they each produce a product. So let's think about this in terms of my favorite example, which is calculators. So let me rename everything. So suppose you have, let's say, a calculator builder that creates calculators, and then maybe you have a calculator with some special functionality, and we're going to call that a programmable calculator. It has your sort of vars, your recall, your store, sort of those kinds of buttons. Whereas your regular calculator doesn't have that. But maybe either one of them could have something like, they could have trig functions, and that's sort of what the builder can decide. But anyway, let us just go into Eclipse, and I'll show you kind of how that works. So this is Eclipse. We have our main class here. We will be doing some stuff with that later. We have this builder interface that doesn't do anything quite yet, but it will soon. A simple little calculator class. This is going to be one of the products that we produce. So it basically has this list of buttons, and that's really how we're going to be representing the complexity here, is with this list of buttons. In the constructor, it just takes in a list of buttons, it copies it over into its own internal list, and then with list buttons, all it does is it prints out each one in sequence. And now we have the director object, which is blank, which we will use in a little bit. So the thing that we need to do is we first need to add some things to this builder. So what I really want to do is use more of a fluent kind of design pattern. So with fluent sort of interfaces or design pattern, it's sort of a technique, sort of a pattern. I'll make a video on it at some point. But you return a copy of yourself, and then you would say something like with button. And so this will just be a calculator with a certain type of button. And so it is string button. And then they usually have a build method, which will give off their the type that they actually create. So this will be a calculator. And this will be a build method. And you'll see the significance of this stuff in a minute. And so what we can do is we can create a calculator builder, calculator builder, okay, and that will implement the builder, right? And so now it's going to be missing two methods, and it's going to complain at us. Let's say okay. What we can do is we can create a private internal list for our internal list of strings for the buttons. We're just going to say equals new array list. No, not array length. Array list. Oh, jeez. No, Java is broken now. Sure, save that. Yeah, okay. Yeah, I don't know what happened there. Eclipse likes to break every once in a while. Okay. So we do that. And then the with button, all we're going to do is we're going to say buttons buttons.add button, right? Okay, and then this, why do you not like that? Oh yeah, because it's not returning this. It's doing buttons.add, and then it's returning itself. And you'll see why this is important in a minute. Same thing, this is actually going to return a new calculator, and it's going to have the list of buttons. So this just copies the list of buttons into the calculator itself. And so now we're going to create a new programmable calculator. Programmable calculator. And that is going to extend calculator. Later, right? And that is going to need the interface there. All right, and so we actually need a builder for the programmable calculator as well. So we'll say programmable calculator builder. And that is going to extend the actual builder. Extends builder. Or no, it's going to extend the calculator builder. Okay, and that's actually fine just as it is. But what we really want to do is we'd prefer to override the build method. And so now it will return it will not return that. It will return a copy of a programmable calculator with buttons. And we need to go up to the calculator builder and make this accessible from there. Okay. So now that will work. And what we also want to do is we want to show that we can change sort of the behavior in here. And so what we will do is for list buttons, we will actually create an override. And then we'll say system.out.print ln. We'll say, you know, listing buttons from programmable calculator. Okay. And you don't like that. Why don't you like that? It is protected. Oh no, it isn't. Okay. Yeah, that needs to be protected. I forgot. And so that will just be from calculator. Okay. And so now, what we can do is we can go to the director. We can say public void build. Yeah, void, oh no, it would be a calculator. Header. We can say build calculator. And we have a builder. We use builder. And then what we can do is we can return builder.build. We can do that. What we can also do is we can set and say builder.with button. And so what this will do is this will basically add the default buttons into the calculator. So we can say add. Maybe we can say, you know, subtract, divide, and multiply, right? But also, in the builder itself, so if we say the programmable calculator builder, what we can say is we can add a constructor, not public void, public programmable calculator builder. We can say buttons.add, or I think we can do add all. Yeah, we can do add all. We can say arrays.asList. And then we can have some programming buttons on this, right? So basically this builder can have some custom logic, and it can return a custom class as well. So we can say maybe the program button, we have the store button, we have the recall button, I don't know, and then the vars button. I know those, I've seen those on TI-83s, so I know those are graphing buttons. Okay, and so what we can do, so now we can say var director equals new director. Then we can say var calculator, or no. Say var calculator equals director dot build calculator, and then we can say var calc builder. We give it a new calculator builder. Then we will just pass in calc builder here, and what that will do is that will give us a normal calculator. We can say calculator.list buttons. Then we copy this stuff again. We'll say programmable calculator builder. Just say PRGM. Programmable calc builder. That'll be a programmable calculator builder. No, programmable calculator builder. And we will have the director, same logic, build it. The same logic, yeah. PRGM calculator. And we'll tell the programmable calculator to list its buttons. So basically, this will show you two different things. So the first one will be this calculator will appear with a list of buttons. So that will show you that the class can be, basically the logic to build this gets encapsulated into the director, is what's going on. And the class is being changed as well as the construction logic. So the construction logic for the calculator, we just give it add, subtract, all that. And the programmable calculator would give it that plus some other stuff, and also we change the line that's printing. So if we just run this, if I can ever find the run button. And so as you can see, listing buttons from the calculator, we have add, subtract, divide, and multiply. And then we have different logic from the calculator itself. So the programmable version has this different printing line. And also it has the original buttons, but it has extra buttons as well. So as you can see, this simplifies the construction logic. We don't even actually have to know what kind of product we're building. We only have to know about the builder. And if we wanted to, we could do some configuration in the build or in the client itself. So we could say, you know, programmable calculator builder with button, and we could add something else, like, you know, of course, I don't know. Let's say this has a graphing function as well. And so if I Alt-Shift-X and then J, you can see that we get the graphing button as well, but this one does not end up with it. So that is the builder pattern. It is really, really cool. I love it quite a bit. Yeah. If you have any thoughts or concerns or questions, feel free to leave them in the comments below. And thank you for watching.